how we draw those if you're in my class. If you weren't, Mr. Walsh did the same thing, I'm sure. How do we do the Spider-Man questions in grade 11? You guys put them out of your mind. Yeah, we had to do like a top view and a side view. Why was it helpful to do a top view and a side view for these? Yeah, they're two-dimensional triangles. Secondly, I can't draw a three-dimensional vector. That's the real reason why it was. I can't draw a 3D picture, okay? But for this, I'm going to change from the top view and a side view for this. So let's look at the side view. It says, from the top view, you are only dealing with north, south, east, west. Okay? Because from the top view, if you're looking at me from heaven, you cannot tell the difference between me and Matt. You don't know that Matt is a foot taller than me. Okay? If you're looking down at us from like 1,000 miles up, right? If you're looking at us from the side, you don't know that I'm facing north, south, east, or west, because you're just looking at me from the side. You see the difference there? Okay, so from the side view, it's only going to deal with elevation. From the top view, it's only going to be north, south, east, west. So this one says an airplane takes off at a ground velocity of 200 kilometers towards the east. So there's your plane. It says it's climbing at an angle of 14 degrees. Does that matter to us? Not right now, it doesn't, okay? Because from the top, 14 degrees, it can't tell at all. From the side, north, south, east, west means nothing to me. What's the only thing that matters? The 14 elevation, okay? Now, this is the other thing we need to know here. So here's my triangle here. So 14. What is equivalent on those two triangles? Where's the 200 on the side triangle? Hypotenuse. Why is it hypotenuse?
That's, I understand. I don't know how to explain it.
I'll explain it for Max. He understands it. Okay. What it is if you're looking down from 1,000 miles up, are you going to see this point? Probably not. You're going to see, I got that backwards. You're not going to see this. You're going to see this part. Okay. So this is going to be, I got this wrong here. Takes off at a ground velocity is 200.
Wouldn't the ground velocity be the resultant?
Yeah, I got that wrong. I got this wrong. Now I'm all mixed up here. Matt's right again. That's going to be your x though, and that's going to be x there. That's what I'm trying to say. Does that make more sense? Now we're good? Now we're right. Now you're right again, Matt. Yeah. Okay, next it says then, because again, he's flying through the air 200 kilometers an hour. Then it says a 20-kilometer wind is blowing from the north. If it's blowing from the north, how do I do that? I want to go south, okay? So I'm going to move this up here. Hopefully. Oh, good. Let's try again. So this is going to be my wind. I should probably put vector signs on there. And wind should be 20. And there's going to be my R right there. Okay, Evan, still good? Okay. Does that make sense for where those things came from on the diagram?
Mr. Sadler?
Yes.
Wouldn't that find the horizontal component of the resultant?
No.
Because
Oh, sorry, so yes, thank you. You're also going to need Z here. I thought, sorry, thank you, I should get rid of that. So what my resultant should be then, thank you, is going to be X plus W plus Z. Now we're good here. Yeah. Okay. Right, because we're dealing with 3 dimensions here. Right. So what you're going to do is, this is difficult to see, okay? Because if you're viewing from the top, from the side view, we're still traveling X this way, but then we're also going 20 here. So your resultant is actually going to be out of the board like this. Okay, that's the logic behind it. Okay? So from the top. So we just define the 3 vectors, add them together, and then find the magnitude. So let's start at the bottom. How do I find X? Let's start with that. Sine law is incorrect. First, it's sine law. I was thinking sine law. It's something to rephrase. It is correct, technically. Keep a look at this. But what's the easier way to find X? Heard somebody say cosine, I hope. I hope somebody said cosine. Is 200 equals 14 degrees. So we calculate that for me then? Oh my goodness. One. I got to invest in the pocket calculator when I need it. 194.06. I'm going to invest in kilometers per hour east. Good. Okay, let's do Z since we're at it here. How do you get what Z is going to be? I'm not going to tell you again. Take a walk, drink the water, please. Take a walk, drink the water. What's that going to be? 2 minus sine 14, good. What's the direction of that one? What was that, sorry?
That's 48.3.
48.38, thank you. I need a pocket calculator. Great. And W, I call that W because that's the wind. What's W going to be? 20. Okay, let's get these in Cartesian vectors because that's what's tricky. Are we relatively okay with what just happened for the X, the Y, sorry, the X, the Z, and the W? We're working in 3 separate directions, and we're going to turn them into Cartesian vectors. Area that leads us to you. What is X as a Cartesian vector? Okay. Somebody help him here. Okay, for this. Go.
194 -0 -0, comma.
Thank you. Because that's like your X value, right? All right, Arden, what is my Y going to be, please? I was going to use W maybe. Use W for Y. What's W going to be then?
0, 20.
Can I call it -20? Yeah.
That won't affect me.
No, that's not affecting anything. Why do I prefer -20 to 20?
Because it's sense.
You want to south or downwards, okay? But you're right, Michael, magnitude isn't what affected, right? Because when you square something, same thing. Can someone be nice now and give me my Z vector, please?
0, 0, 48.3.
Wonderful. Okay, I'm going to say that an R is going to equal X plus W plus Z. Can somebody named Matt tell me please what vector R is going to equal?
It's just the 194.6 minus 20, so 48.3.
Yeah, but not the plus though, okay? It's because you got to think of components, right?
This way you don't have to put directions or anything like that.
Right, so you see what I did there, right? I just, because it's a comma, comma, comma. All right, Brendan, how do we take the magnitude of R? Because that's what we're actually looking for here.
Let's see. R equals the square root of
Yeah.
94.06 squared
Yeah.
minus 20
Plus -20 squared. Yeah, okay, good.
plus 3 squared.
Right. And I'm going to ignore units for right now. Just for that. Christina, were you able to get an answer for that? Or can you try and get an answer for that? And when I say Christina, I mean everyone. Probably you're trying to get an answer for this too, right? Play along, please, okay? Can you play along? You want to be in my good books on the first day, right? All right, 194.06 squared is a big number. -20 squared is 400. I can do that one. 48's a big number too. Am I recording this, by the way? Yes, I am. 200.99.
Yeah.
201, we'll call it.
Yeah.
201.00. So this would be the ground velocity. Okay, the ground velocity means you're looking at that plane from the ground. That's what it is. If they wanted the air velocity, what would you ignore? How would you find the air velocity? Not you, somebody else. Knows that, right? So the air velocity would just be the x and y components, okay? I'm not mean. I'm not like going to be a stickler for that, okay? Like I'll be very clear what I'm looking for, okay? So that's the ground velocity. Now, why can I not just easily find an angle for this? Like it says, what's the angle? What's that? Yeah, we do good. Okay, but why can I not just say, oh, what's the angle? Like, you know, it's always like 48 degrees, and you can easily find it with like 52 angles. Yeah, you have to find it relative to something. That's the thing always. Okay, right? So, because think if I'm spinning this one, let's say I'm calling Superman, go with it here. Okay, I'm rotating this one going up. Right? What's my angle compared to what? Right? You need like a starting point to compare it to. Okay, so and that's you got to think in 3 dimensions is a little trickier. So that's why that's I'm glad whoever asked for 25 feet or whatever it was, because that's a good way to show relative to angles. Okay, does that make sense? Sort of. Okay. I would strongly recommend you get practice your word problems because your assignment, which you will get probably Thursday, will have lots of them. Okay, so I'll love redo the problems.
Would you want it written out like east something south
Exactly.
at 14 degrees?
No, that's fine. I think that's fine for that. I think.
Who put this here?
I still stole it? I guess I did. Okay, 36 says, ooh la la, CN Tower is 553 meters tall. A person is south of the tower in a boat on Lake Ontario. It makes an angle of elevation of 10 degrees to the top of the tower. Great. A second person is sitting on a park bench on a bearing of 60 degrees relative to the tower, observing the top of the tower at an angle of elevation of 9 degrees. Wow. Determine the displacement of 2 people. If this doesn't make the hair stand up on your hands or shoulder, I don't really have hair. Head, let's say. Okay, I don't have any hair on my head, so it doesn't stand up here for me. Okay. So 36. This will be a lot like the Spider-Man questions from grade 11. Okay. I'm going to draw the best thing I can in the top view and the side view. From the top view, CN Tower is going to be right here. I'm going to call that CN. You know, CN Tower from Google Maps is just a dot. That's all it is. Like, it doesn't look impressive. Okay, it's not much. So we'll be a shadow too, yes, okay. We'll assume that right now it's going to be a straight, plain dot. It says person A is south of the tower. How am I going to draw that? Straight south. And that'll be an A. And it says it makes an angle elevation to the top of the tower. We'll leave that for right now. Okay. Person B is sitting on a park bench on a bearing of 60 degrees relative to the tower. Who are we up to right now? 80. What does an angle, relative angle of 60 degrees mean? Sorry? No, not to the ground. Well, it just says, sorry, a bearing of 60 degrees. How do you do a bearing of 60? Yeah. So what's going to be is here, this is like your north, right? So it's going to go something like this, and there's 60 degrees, and there's person B. It says determine the displacement of the 2 people. That's actually what we're looking for right there. Okay. Now, if that's all the question was, that'd be fine. What's the problem with solving that triangle? There's no, what was that?
Well, they're not like level.
Yeah, they're not level, first of all, okay? The second problem is I have no distances or anything like that, right? So that's going to be an issue for me here. So we'll deal with that in a minute here, all right? Are we okay on where the top view came from? We're going to have at least 2 more triangles, maybe even 3 for the x's. The second triangle is going to deal with, this is my side triangle from the CN tower to A. So all the side views will only have things like elevation on it. So what I'm going to do is I'm going to draw a beautiful tower, looks like this. It's going to be 553 meters tall. It says there is an angle of elevation of 10 degrees. So going back to grade 10, the angle of elevation looks just like this. Now, Tyler, you're new to the class, so I'm just going to share something with you. I'm a horrible triangle drawer. Like I'm hideously bad, okay? You shouldn't knock it out, you say, no, you're fine. So please just go by the dimensions on there, that's clearly not a 10-degree angle, okay? But go with it, yes?
Can you draw it differently?
Yes, if you prefer, yeah, if you're left-handed, don't need to slant. Left-handed people are wonderful, you're a left-handed person. But if you want to draw your vectors going the other way, there's no issue with that. Page one, I lost my thing here. What page are we on? 401. Okay. All right, so here's the thing. What vector from here is rated left? What vector on the side triangle is related to the top? Like where is the same as what? It's the same as what?
Well, from A to C entire is the same as hypotenuse again, right?
I don't think this is hypotenuse. I'm calling this
Or
this.
that, sorry,
I'm
yeah.
calling that and that. I'm calling it. Okay. So you think if I have a ladder like this and I look at it from above, it only looks like a little bit as higher than a C.
So you just change the x's to like a
Whoa, goodness, holy moly, sorry. Goodness gracious. That's going to be A, how about
M.
A? And for Michael, no Michael. Okay, the other side view is going to be an angle of elevation. Now here's a question for you, Michael. 9 degrees, I'm going to call that B. We assume they're at the same.
Person B sitting on a bench, right?
Can we assume they're both on the ground though? We're going to have to, I think, right? I think so, right?
Well, if these two heights are the same, then yeah.
All right, there we go. Okay, so this is this exactly the Spider-Man question, in fact, there's no difference. It's exactly the Spider-Man question, right? The two webs and all that. Okay. It's 9 degrees, it should be.
9?
Yeah, sorry, 9
Okay.
degrees, right. Okay, so then all we're going to do for this is we're going to do cosine law a few times. Do you want to do this in terms of x, y, and z? I guess we'll do this in terms of vectors. The thing is, in this question, it looks to me like they share the same elevation from the way of the wording, right? I don't think there's another way. It doesn't say like the person's higher or lower than the ground, I don't think. I will give you one on your test that says that there is a 20-meter building. Mr. Sadler is sitting 5 meters above sea level. Okay, when you're looking at this, or whatever, there'll be one like that that's you need the Z in here as well. So this one here, the way I'm reading the question, everyone's on a flat ground. The way I'm reading it. Is everyone else reading it that way? No one even knows what I'm talking about. Okay, so yes, I'm going to assume it is. Okay, so as far as A, I'm going to say that tan A equals 553. What's tan 10 is 553 over 10. All right, Joe, can you be brave, please, and figure out what A is and what B is, please?
A is 2,136.2.
Right, and B is?
3,491.
A little slower, 3, 4.
91.
Yeah. Now, if you're a physics student, we would deal with sig figs here, okay? This is where the thing. If you're measuring a 10 or a 9 degree angle from 3,000 meters away from the CN tower, right, it's going to make a big difference, right, as far as the accuracy for sig figs, okay? And let's assume right now that it is a perfect measurement of 10.000000000 degrees, okay, right? But that's where sig figs are actually important for a question like this, okay?
Is A directly south of the tower?
Yes, A is directly south, yes. So this is 3136.2. This is 3491. And this looks like cosine law. Nate, can you recite from memory cosine law, please?
C squared equals A squared plus B squared minus 2AB.
I need my theta in there too. How would I find what theta is? Because this is tricky. Amy, it's your turn conveniently. Go ahead. 180 minus 60, which is 120. If you like right triangles, 60 and 30 is 90, and another 90. Okay. So I'm going to do that as x squared equals 313. So this isn't really a vector problem, is it?
More just 3D images.
All right. Rebecca, I'm going to get you to use the power of your calculator. Solve for x. When I say Rebecca, I mean everyone in the class, by the way, is going to do this. All right. Just, expect questions like 35 and 36 on your test, I can guarantee.
And
Okay, right.
exam.
And on exam too, yes, definitely.
Cool.
I was just reminding Tyler, since he's storytelling, one, I want to remember your name. Secondly, though, because we actually had this conversation. I was just reminding Tyler there is a midterm in this class. I haven't got the date yet, but it sounds 3 midterms actually. But it sounds like it's going to be about the tomorrow. Don't start there. 25th, probably about the 3rd week of April. I think is when it's going to be. So the 25th, and then 2 weeks, and then the Monday after that.
I'll come to Exodus 5,732.
5732, thank you. 5742. So confirm. No one else is there? Oh boy. 50. Therefore, their distance. Does that match the back of the book? I'm fairly certain that it is. So I don't see any Z's even happening in there. So I think we're okay. I don't see any Z's in there. That really isn't much of a Cartesian question, I don't think. You're just getting used to playing with three-dimensional word problems.
What question is that?
36. Okay, sort of good. What else was difficult from yesterday before I started today's lesson? Because those are sort of the biggies. You get the idea of a 3D word problem to get then like the projections and stuff like that, and that distances and projections and all that stuff you should be able to do. And IJK and adding vectors and all that stuff. Good? Okay, I'm going to stop the video. I'll start today's lesson. If I don't make it through, that's okay.